In this lesson, we'll focus on various network attack techniques and indicators. A network attack is a general category for a number of strategies and techniques that threat actors use to either disrupt or gain access to systems via a network vector. Let's dive in. We'll begin by discussing distributed denial of service or DDoS attacks. A denial of service or DOS attack is anything that reduces the availability of a resource. It can target physical hardware, like servers and routers, or exploit software vulnerabilities to disrupt services. Malware-based DOS attacks can even destroy file systems or overload hardware components like CPU, memory, storage, or network bandwidth. DDoS attacks are a specific breed of DOS attacks. They're called distributed because they're launched from multiple sources simultaneously. Threat actors compromise machines and use them as handlers in a command and control network, forming a botnet. These botnets are then used to carry out DDoS attacks. Assembling and managing a botnet large enough to overwhelm a network that has effective DDoS mitigation measures can be a costly endeavor. This has prompted threat actors to devise DDoS techniques that increase the effectiveness of each attack. In a distributed reflected DOS or DRDoS attack, the threat actor spoofs the victim's IP address and attempts to open connections with multiple third-party servers. Those servers direct their SYN-ACK responses to the victim host. This rapidly consumes the victim's available bandwidth. An amplification attack is a type of reflected attack that targets weaknesses in specific application protocols to make the attack more effective at consuming target bandwidth. Amplification attacks exploit protocols that allow the attacker to manipulate the request in such a way that the target is forced to respond with a large amount of data. Recognizing DDoS attacks is crucial, but it can be challenging. Look for unexplained traffic spikes with no legitimate explanation. To mitigate these attacks, we often need high availability services like load balancing and cluster services. However, DDoS attacks often involve spoofed source addresses, making it challenging to stop them at the source. Now, let's shift gears to on-path attacks. In on-path attacks, threat actors position themselves between two hosts, capturing, monitoring, and even modifying their communication. This means the hosts might not even realize that they're being intercepted. Another attack focuses on the domain name system. The domain name system, or DNS, resolves requests for named hosts and services to IP addresses. Name resolution is a critical addressing method on the internet and on private networks. There are many potential attacks against DNS. On the public internet, attackers might use typo squatting to confuse victims with malicious sites. DNS can also be exploited in DRDoS attacks or by hijacking public DNS servers. If threat actors have access to the same network as the victim, they can use DNS-Based On-Path Attacks. They respond to DNS queries with spoofed replies, often in conjunction with denial of service attacks on the victim's legitimate DNS server. In some cases, rogue DHCP servers might be used to redirect clients to DNS resolvers controlled by attackers. Another DNS attack vector is DNS Client Cache Poisoning. Here, attackers manipulate the hosts file, which is a text file containing a known name to IP address mapping. This cache is checked before DNS resolution is used. If this cache is poisoned, it can redirect traffic wherever the attacker chooses. Think of it as altering road signs to lead people astray. DNS server cache poisoning aims at corrupting the DNS server's records. Attackers can perform DOS attacks against the server holding authorized records and spoof replies to other name servers. DNS server cache poisoning can also involve making the victim DNS server respond to recursive queries with false records. DNS can also be misused for command and control of remote access Trojans. To detect DNS attacks, monitoring DNS event logs is crucial. Look out for unusual query types, suspicious IP address ranges, or spikes in DNS lookup failures. Wireless attacks are security threats targeting wireless networks. Let's look at a few. A rogue access point is an unauthorized network access point connected to a network. It can be set up maliciously or accidentally. An evil twin is a rogue access point mimicking a legitimate one, often using similar SSID names to deceive users. For example, a malicious user sets up an evil twin with the same SSID as a coffee shop's Wi-Fi, intercepting users' data when they unknowingly connect to it. A wireless denial of service attack prevents clients from connecting to the legitimate access point. This attack disrupts wireless networks by interfering with signals or targeting clients. Attackers can jam legitimate networks with rogue access points or send spoofed frames to disconnect clients. The final network attack technique we'll look at in this lesson is a wireless replay attack. A replay attack is an attack where the threat actor intercepts some authentication data and reuses it to try to reestablish a session. A credential replay is an attack that uses a captured authentication token to start an unauthorized session without having to discover the plaintext password for an account. Well, that's it for this lesson. In this lesson, we went over several network attack strategies. First, we looked at various denial-of-service attacks. We then reviewed on-path attacks. Next, we discussed DNS attacks. And we finished the lesson by looking at wireless attacks. Being familiar with the variety of ways networks can be attacked is one of the most critical aspects of cybersecurity.